Hello everyone. Good good afternoon, good evening. In this session, we have presenters from three countries. One is Pakistan, Egypt. Sorry, four countries: Pakistan, Egypt, Ecuador, and India. So I welcome you all on behalf of Team World S4, and welcome to the technical session 1A of fourth World Conference on Smart Trends in Systems, Security and Sustainability, World S4 2020. Due to COVID-19, we all are going through a new normal phase, and the team of World S4 wishes you a safe and healthy time for you and your well-wishers. We are constantly trying to overcome the challenges that research community is facing at different level. We at Global Knowledge Research Foundation are fully committed to contribute and enhance the digital experience in research activities. To continue further, this conference has received tremendous number of submission, which has crossed more than 700 plus numbers from 40 plus countries, marked through direct submission and special sessions, out of which 142 papers were accepted by technical review committee. And once again, we all would like to congratulate you for your research work and to be a part of the success story in fourth version of this conference. Further, I would like to welcome our session chair to take on this session. Uh, our session chair is Dr. Nisarg Pathak. He has been an astute and research-oriented professional with 14 years of experience in teaching and carving state, national, and international events globally. Currently, he is working as a professor at SGSP India. Being a mathematics scholar and computer science professional, he is actively involved in research of data mining and big data analytics. He is an PhD and master's and has more than 50 publications to his credit. His other tenures include research fellow at Indian Statistical Institute Kolkata and Indian Institute of Science Bangalore. Yes, Dr. Nisak Patham, again we welcome you and we start ahead with our technical session. So I would like to invite first Aisha Wakar Mir.
Hello, Assalamu alaikum. Greeting to all of you.
Yes, assalamu alaikum. And I'm just giving a permission you to share your presentation.
Sure. Can I share the screen now?
Yes, now you can share your screen.
Is it visible?
Yes, it's
Yes, yes.
visible.
Okay, let's start. Assalamu alaikum and greeting to all of you. I hope everyone is safe and sound in this globally chaotic situation. My name is Aisha Wakar Mir and I'm presenting from Pakistan. The topic of my research is robust visible light communication in intelligent transportation system. Here is a brief outline of my presentation. What comes to our mind whenever we come across any of these such conditions in our daily life? I wish I could avoid this traffic jam. I wonder if I know earlier that the car in front of me is about to apply brakes. Can I find a vacant parking space before even entering the area? Can I totally avoid a traffic jam due to an accident? The answer to all these questions is intelligent transportation system. With the increased traffic, greater congestion occurs, which causes increased probability to accidents. This shows that higher safety and maintenance is required for intelligent transportation system. A concept based on Internet of Lights is the latest trend in this regard, in which connectivity through light occurs, which increases the quality of travel and decreases the probability of accidents, which increases safety. Intelligent transportation system is an emerging system which comprised of advanced information and telecommunication networks for users, roads, and vehicles. This merges with existing technologies like wireless communication, computational technologies, sensing technologies, and video vehicle detections. We have LED lights everywhere in our surroundings, like traffic lights, street lights, and etc. The research on visible light communication caused infrastructure having LEDs, which provided numerous opportunities in an ITS. A basic communication system is as follows. To the digital form, from the digital form through input transducer, from there it is transmitted via channel with a noise. It gets received through an output transducer and it is sent to the destination in the same format as it was sent in. Here is a brief study of the literature review I had. I've gone through certain studies in which red LED light was considered as a transmitter, while in some cases a traffic signal was considered as transmitting source. Some researchers showed a hybrid approach as well. To some, they were only countering the noise effects. Some people approached sensor technologies for their research, and some briefed through the analytical model as well. After going through all of these, I was able to find some research holes, like the noise generated by other light sources was one main issue. The heavy traffic, the peak times, and locking of visible light was another issue. Different distances between transmitter and receiver was another issue. For these things, I have researched and gone through some papers, and they have come up with certain solutions. Like for the first problem, they said that a combination of a photodiode with an optical element will be able to filter out the background noise. For the second problem of heavy traffic, they said that the VLC could perform broadcast due to the movement of vehicles providing site areas. And for different distances between transmitter and receiver, the availability of multiple routes of communication allowed contact between vehicle and avoid the collisions. And greater challenges also lie in the interference generated by other climatic conditions like fog, rain, snowfall, smoke, and etc. Analysis of visible light communication on different wavelengths was also there. So after going through all of this, I think I decided to examine the effects of different wavelengths, that was different color LEDs, for different weather conditions. For that, I proposed some parameters for my system, for my mathematical model, in which I considered that I'll be considering four wavelengths of LEDs, that will be for red, yellow, green, and blue. And for four weather conditions, that will be clear, rain, snow, and fog. And infrastructure which I considered for my mathematical model was infrastructure to vehicle communication. And a transmitter will be a static traffic light. And for the receiver point of view, I'll be considering a photodiode being implanted onto the windscreen of any of the vehicles. And the parameters which were observed for this analysis will be signal to noise ratio, optical power received, and a bit error rate. And at that point of time, when I started my work, I thought that there will be certain parameters, certain numerical values which I'll get at the end of the day, and I'll get some tables like this in the form of this. As I discussed earlier, that my simulation setup was a static transmitter and a car photodiode being implanted onto the windscreen of it. So it's the model for that. A basic transmitter model which was considered for the system was that a traffic information unit may be pre-recorded, or a real-time scenario can modulate the system information, and through the output driver, the information can be transmitted through the traffic light. And at the receiver model, at the receiver end, basically the photodiode will receive the message, and through the bandpass filter and demodulation techniques considered, the output will be displayed inside the screens of any of the cars, or any of the information being transferred to the receiver end, that is usually the cars considered in my case. For the methodology purposes, I consider, as I discussed that earlier as well, that for the methodology part, I considered four weather conditions for four different LEDs. So we can say that for the clear weather condition, I analyzed the system for red, yellow, green, and blue LED. For rain as well, I considered red, yellow, green, and blue. Similarly for the snow and for the fog. And these were considered for one parameter, that was signal to noise ratio. Similar parameters were analyzed for optical power received as well and for bit error rate. The results are now as follows. And after that, I can say that all these values were graphically represented in this form. In this, we can clearly see that how the blue LEDs had a better result as compared to the rest of the three LEDs for signal to noise ratio as well and for optical power received as well. So to conclude my analysis for the system, I can say that I had a mathematical model in which I examined clear, rain, fog, and snow attenuations for different wavelengths, in which an infrastructure to vehicle system was considered. For snow, I considered dry snow parameters, and for rain, I used Japan model at moderate level. For fog, I considered dry fog at moderate level, and the performance parameters were optical power received, signal to noise ratio, and bit error rate. And the analysis concluded as that for the clear weather conditions, I had 463 nanometer is the most appropriate wavelength for transmission, which was actually for the blue LED light, the 463 nanometer was. And it had a signal to noise ratio of 127.69 dB and an OPR of minus 23.7 dBm. So similarly for the fog, they had 14.02 dB result, and OPR was minus 22. Rain, we had certain SNR for blue were considered better as compared to the rest of the three LEDs, and for the snow as well. So overall, I can say that 463 nanometer, which is for the blue LED lights, is observed most appropriate for clear, rain, and snow conditions for my case. I guess it's, I would like to conclude it over here. Thank you for your patience, all of you. Any questions if needed?
Thank you. It's in very
I think I was
precisely.
fast,
Yeah.
I guess I was a bit fast.
So very precisely presented presentation. First of all, congratulations for keeping very hard and strict deadline of a presentation. Congratulations to you. Very obvious question is how the infrastructure, if we plan it, this kind of system would be feasible to have in any of the city area.
Sir, can you just repeat the question because I cannot hear you a little more clear?
Okay, if we wanted to have this kind of intelligent traffic system,
because
the infrastructure requirement to, let's say, a town level or a city level, how much cost and how feasible it is to set up?
So I would consider it like first, I would say I had a mathematical model in my mind when I started working on this research. My supervisor and I discussed for the future works. He said that first you have to implement it on one building, just consider it a university building, and then you consider it the second building, and then you can move towards switching towards the whole city and the smart cities concept and everything. So definitely I have to have a brief analysis on that as well, how much cost I will be requiring for that. But for now, till now, which I have done the work, I have just worked on the mathematical model, not on the cost related scenarios or in the real time scenarios.
Okay, now one more quick question. One more very quick question. If
Yes,
at
sir.
all we look at the other communication channel, the peer-to-peer communication or one-to-many communication, it is based on a specific numbers. That number can be frequency, that number can be wavelength, anything, right?
Yes, sir.
Here, if you think of a blue LED light, which gives you a very unique result, if you fix the same kind of blue LED light to more than one building, and if there are certain shadowed parts where the lighting effect of two different buildings are colliding,
Yes, sir.
that intersection part you have to set, you have to analyze, and you have to segregate it.
Right, sir. I get it. That these will be the pit holes in my future works. I get it.
All the best.
The effects for if two buildings if I'm clearly getting the question, it's that if I'm transmitting the information from one building with the blue LED lights, and for the second building as well I am considering the blue LED lights, so when they'll be intersecting, so the information will be um,
Exactly.
yes,
Exactly.
getting lost. I'm
Pinpointed.
getting your point. That
So
will fit.
kindly work on that.
Yes, sir, definitely. I'll try to work on this point as well.
Good going. All the best.
Thank you so
Okay.
much, sir. Thank you so much.
Okay. Thank you, Aisan. Thank you, Dr. Patak. Now, next, I'd like to invite Dr. Uh, Mari from Egypt to present a paper on autonomous parallel car parking. Yes, Doctor. Now you can share your screen.
Yes, okay, thank you.
Yes, welcome.
Yes, is the screen shared with you?
Yes, yes,
The
we can see
voice is
that.
okay.
Voice is also okay. Please go ahead.
Okay. First, you in this prestigious conference. My name is Dr. Mardi Mansour from the Electrical Engineering Department, Faculty of Engineering, the British University in Egypt, Cairo, Egypt. Our paper title is called Autonomous Parallel Car Parking. The contents that I would like to discuss: first, the problem statement, the paper contributions, and autonomous parking in industry, the car design we use, the proposed system, and the simulation and results, finally the conclusion and some of the references used. Let us start with the problem statement. Actually, what was the motivation behind the choosing this specific topic is that generally the number of drivers are keeping increasingly as we move on. Also, accident, there are a lot of accidents has been realized in the parking spots, especially if these parking spots are of limited space. And when some kind of accident happens in certain parking spot, this may cause erode traffic outside this parking spot in the street. Also, it is a time consuming, the parking itself, sometimes it is a time consuming for especially newly drivers. Also, it is a time consuming if this parking space is highly condensed where few spaces are available for parking. So our paper contributions: first, we designed an efficient and easy parallel parking system that allows a certain car to autonomously park or park itself. Also, we added some safety features to our prototype, including open door detection and alcohol detection. Also, the autonomous parallel parking system that our prototype implements helps in reducing the parking congestion and consequently the road blockage, decreasing this rate elderly, less skilled and disabled drivers in this maneuver, which is the parking, saving also the driver's time and effort, and of course relieving any stress from them. Finally, optimizing the fuel that may be wasted in going forward and moving backward in order to park manually. Also, we would like to highlight the autonomous parking in industry. This topic is really has grown importance from the industry side. For example, a manufacturer like Toyota in 2003, it introduced the intelligent parking assist system in the car, which is Prius. Then 2006, again, it introduced this system, which is the intelligent parking assist with parallel and angular parking maneuvers in its car type, which is the Lexus, and so on. Here, you see, as you move forward, every year and then, or every 2 or 3 years, you find a new car manufacturer that introduces the autonomous driving, which includes the autonomous car parking in its cars. Coming nowadays, also in Volvo, you'll find sensors that detects and notice lanes and other automobiles that helps also the cars in autonomous parking and autonomous driving. In BMW, for example, the I series, it embeds in it the Wi-Fi and high definition digital maps and so on, and some computing facilities that also helps in this process. Also in Nissan, you will find safety shield inspired technologies that monitor 360 degrees read around a vehicle, also that helps in this process. It's worth to note that there are different automation levels that starts from 0 and then goes to 4. The autonomous parallel parking was first introduced in level 1. Level 0 has no automation. Level 1, when they started to automate the driving process in level 1, they also introduced the autonomous parking, because actually it is one of the main functions that will help much the driver if it is automated. Coming to the car design, first we modified an RC car, which is its abbreviation is stands for radio controlled car. We added some hardware components in it, like the ADMECA controller and LCD screen. The LCD screen, it was very useful in displaying the parking state to the driver. For example, if a certain parking spot has a reading, which is displayed by the LCD. Also, the LCD screen was very useful, and it acts as a major element in debugging and optimizing the system, because it shows the status of the hardware components and the initialization of these hardware components. Also, we added the dual motor driver, DC motor and servo motor. It's worth to note that the servo motor receives a signal from the microcontroller in order to know which direction to turn to. Also, we added 2 infrared sensors to the RC car, one located in the front and the other located in the back, because it helps the car in stop. It informs the car to stop moving if the distance between the car and a certain object comes very close. The ultrasonic sensor, we added one ultrasonic sensor, which is located at the right-hand side of the car, to align the car to certain parking spot. How this is done? Simply, the ultrasonic sensor measures the distance moved by the car, and if this distance is empty, this is equivalent of the length of the empty spot, and compares the distance moved by the car. If this distance is empty, compares this empty distance or empty length with a length specified in the program code, which is the length of the car itself. If the length of the car matches the length of the distance moved by the car, so this means this empty spot is suitable for the car to park itself. Here, as you see, this is an autonomous car that has different technologies embedded in it in order to help it in the autonomous driving and in the autonomous parking. For example, here, the ultrasonic sensors that are on the right-hand side. Coming to the proposed system, First, it's worth to note that there are three types of parking patterns, either parallel, front, or back. In our project, we targeted and focused on the parallel parking, which is commonly used. First, in our proposed system, we implemented the previous car design by modifying the RC RoboCar or the RC car in order to add the different hardware components and the sensors that we have just discussed. Then after this, we run the program on the car circuit, the program which is used for autonomously parking the car. After that, we use the LCD in order to display the initialization of every hardware component to make sure that every hardware component is working well. After this, when the auto park switch is pressed, the car will start moving. After, of course, all the hardware components are being initialized successfully. Now, the auto park switch could be pressed in order for the car to start searching for certain empty space. When the ultrasonic detects an empty space, which is length equivalent to the length specified in the program, the LCD, it will send this reading to the LCD, where the LCD will display that there is a parking space has been detected, and also the equivalent length read by the ultrasonic sensor. And here, as you see, here this is in a garage, and different vehicles they are already parked, while this vehicle is searching for an empty space. When the empty space is found, here the car now can execute the program in order to parallel park itself.
Yes, sorry, Marvi,
Yes.
to interrupt, but please be a little quick. Thank you.
Yes. Okay. Sorry. Okay. Then after that, the two IR sensors will be used while the car it is parking itself in order not to hit any other car in front or at the back. Also, we added some safety features like the alarm, the door sensor, the alcohol sensor. For example, the alarm informs the driver with the initialization status for every hardware component. The door sensor will prevent the car from parking if the door is open, same as in real life cars. Also, the alcohol sensor will prevent the car to move and to park if an alcohol detected. Simulation and results, we used the Proteus program to simulate our system, and they were satisfying. After that, we implemented the hardware system and tested it. The prototype of our car detects a suitable parking spot. Then the car parked itself in this empty space. If the space detected is smaller, the car will continue searching for another suitable space. Also, we tested all the safety features like the alcohol and door sensor, and they all worked well too. Here, this is the simulation of our system on the Proteus program. Here, the Atmega microcontroller, two IR sensors, the LCD that displays the initialization. Coming to the conclusion, our project implemented the autonomous parallel car parking. The prototype includes a car system that executes the parallel car parking program. Our future works includes adding, we would like to add other safety functions like, for example, fire detection and so on. We recommend using this type of system because actually it assists various types of drivers, and also it contributes and helps to a safe and relaxed journey. Here's some of the references used. This is my bio. Thank you for your kind attention, and again, you are welcome to have any questions. Thank you.
Can we move to the next presentation, please, sir?
Yes. So if anyone has any query with Marvi, you can write into the chat box. and we have a quick reaction um, tab bottom in the bar. So we will give a quick reaction because of the virtual conference. So if there might be a physical, we can clap or appreciate the presenters. So now we move ahead with our next presentation. It will be by uh, by Maria. She will present a paper on cybersecurity attacks on smart home during COVID-19 pandemic. Yes, Maria, now you can set your screen.
Good afternoon, everybody. Please wait a moment. I found my presentation. Okay. My name is Maria Fernanda Casares. I am from Quito, Ecuador. I am clinical psychology. For me, it's very important this topic of the people using the technology, how who the people behave thinking in different situations. In the afternoon, I speak about cybersecurity attacks on smart home during COVID-19 pandemic. Let's start. First, it's important to analyze the scenario in this moment in the world. The people, the most people work at home. Smart home design could increase the attacks surface, which allow that the number of attackers increase by 35%. According to several cybersecurity firms, worldwide have determined attacks have existed during COVID-19 pandemic. This increase for the attribute for the attackers use different strategies for the vulnerability or infringe the security in the homes of people. Coronavirus outbreak allow the access for the people find different information. Palo Alto says the malicious URL increase 1,103,000 dominions. For example, COVID-19 mobile point up. Attacker also use words associated with events that occurred during the COVID-19 pandemic, such as the people sharing flies, food, or the liver. This word is using for the attackers we analyze. We found words in the malicious URLs words. Sorry. In Spain, results of the one investigation, the people during COVID-19 quarantine look for topics related to health, labor, or business regulation. We take the report of Google search. We look the 100% is coronavirus. The term coronavirus is the most word find the people in the confined. In this scenario, it's important consider the people changing in different aspects. In this picture, adults are looking different resources about has information, for example, newspaper, TV, or internet. The children have a connection in electronic device. So the people have different behaviors and different thinkings. In this slide, we show the different aspects. People try found information relate with guidelines for drive their emotion and behavior to face the pandemic. The cultural is important for the most people. We need different guidelines for now is right or incorrect. So people find information about this topic. Other aspect is the people means connection emotional with others people, in special who are significant in their life. For share experience and great solution to face negative problems and feelings. It's important for the people, this interaction for the they will change the moods and develop a vision of hope for the future. Another aspect is the adaptation. The people in the world need adaptation to the new normality. It's important find different information for learn about new habits and new behaviors. Another aspect is the people have predict thinking. Predict thinking is very important for the people for anticipation problems and planning strategies. In this moment, uncertainty is permanent in our life. So cognitive level is important, planning different aspects so about this topic. These behaviors and attackers and scenarios carry this problem. Phishing is the form for use the attackers in this moment. some relevant information about this topic. The database cost enterprise an average of 3.92 million. Google say that blocks more than 100 million emails with phishing every day. Gmail has detected 18 million emails a day. Attackers have taken advantage of the increment in the use video conference tool for teleworking or teleeducation. This situation, say some bombing is present in different moments in the moment. And so attacks during COVID pandemic, phishing relate with coronavirus, 1010, new confirmed case in your world. Phishing is the form more using with the attackers. So it's important for us, another our share. What is the problem in this moment? Smart architecture, the smart home is vulnerability. The house, traditional house, which router by service provide, distribute the network servers in the house is not common have perimeter, security, firewall, intrusion prevention systems, or web filter expand. The homes is vulnerability in this moment. In the slide, could be important for the understand the situation for vulnerabilities and dynamics in the pandemic. Reconnaissance. Abraham Maslow says needs classification of needs when what that the attackers using for use or elaboration, the weaponization, semi-automatic, manual, and automatic. These weapons delivered for email, web, social network is exploration, installation, command control, infiltration. The phase and the problem in these contexts increase the complexity and time to resolve the cybersecurity incident is one alternative. The people is vulnerability in your home, but don't have tools or necessary tool for defense. So I think that people additional change the different forms that make of decision. The life is changing for all people in the world. So thinking the better with alternative when found information in the internet.
Yes. Sorry, Maria, but please conclude uh, because we are running after time. So please
In
conclude in 1 to 2 minutes.
is my last slide.
Okay, okay,
Uh,
okay.
Thank you for
Oh,
your attention.
yeah, good. Um, yes, Dr. Nisak, do you have any question with Maria?
Yes, so very first question is it's a very good survey paper that she has done a good survey regarding the attacks what took place during the pandemic. Now my very fast point goes with the very first slide. She said that the attacks, cyber attacks increased 35 percentage. Fine. So I would like to draw the point that increase, I agree, but with there should be an evidence that it is because of the search or use of technology related to pandemic or COVID. First thing, whenever you are stating 35%, it has to be due to COVID. The person has searched COVID, person has installed the app related to COVID, then they get into any kind of cyber attack. Second thing, whenever you are presenting these kind of stuff, there has to be at least comparative study that what was and what is. So I request that whenever the next version of the paper you are going to present anywhere, would hardly recommend you that please have at least some good comparative study what took place and what is during the COVID. So
Okay,
yeah, my many congratulations goes to Maria and keep up the good work doing.
Okay, okay. Thank you, Maria. Yes, if anyone has any question with Maria, please write into the chat box. Uh,
thank you.
yes, thank you,
Thank you
Maria.
for your words.
Yeah,
Thank you.
welcome. So we move ahead with our next presentation. It will be by Amar Abdelai Mourad from Egypt. Um, he will present a paper on a novel approach to catch replacement policy model based on genetic algorithms. Yes, Amar, you can share your presentation.
Yes,
Yes.
yes, yes. Hello, doctors. Can I present this presentation in
Yes,
this style? Okay,
Yes.
yes,
Yes,
please,
that's
please.
fine.
It's
okay,
visible and audible.
okay. I am Amr Abdelhai from Egypt, from Arabic Academic for Science and Technology, and I will introduce now the title of the paper, the novel approach to cache replacement policy model based on genetic algorithms. Okay, okay. My voice is clear.
Yes, very clear.
Yes. Okay. The outlines. This is outlines, introduction, literature review, the genetic algorithm caching model, and the proposed algorithm, experimental results, and conclusion. In this conclusion, this is an introduction title. Okay, the cache replacement policy. Yes, the caching improves performance by keeping recent or often used data items in memory locations that are faster or computational cheaper to access than normal memory stores. Okay, when the cache is full, the algorithm must choose which items to discard or to delete to make room for the new ones. Okay, cache replacement. The cache replacement policy has a various algorithms, like the frequently used cache policies in the database, like LRU. Yes, like the LRU. Yes, list recently used, and LRFU, and like clock algorithm, 2Q algorithm, which used in SQL Server database and Oracle database. the clock algorithm, which used in data DB2, okay, database DB2. Yes. The major problem is that these algorithms aren't very effective because these algorithms doesn't consider different different access pattern for the block, like sequential pattern, looping-like pattern, temporally clustered pattern, probabilistic references pattern, and so on. Yes. Then the solution is to handle how to dynamically modify the cache replacement pattern in response to changes in the access pattern. That is the solution. But yes, sorry. This is the importance, yes, this is the importance of cache replacement policy. Yes, the evolutionary computing techniques, the concept of evolutionary algorithms has been used to resolve several computation problems requiring adaptation and optimization to altering environments, okay? And the genetic algorithms are considered under the umbrella of evolutionary algorithms and evolutionary computation, yes? The literature review, yes. The LRU, yes, and the LFU, this is the most common algorithms used in the old databases. LRU, least recently used algorithms. It replaced the least recently used pages that haven't been accessed for the longest time. It's easy and simple to implement it, okay? But LRU can take benefits of such pages with long-term utility. In the long-term utility, the LRU maybe not inappropriate, not suitable, like file scanning or scan data, sequence of requests of pages that aren't requested once more. So scan may replace all pages. In this case, the scan may replace all pages in the cache, regardless of whether the pages will be used again or not. And says the same LFU, it rejects or it rejects the blocks in the cache which was requested the fewest number of times. It performs fully in WIP requested sequences. It collects absolute blocks with past high frequency counts. Yes. This is but as I said, this is the demerits or disadvantages of LRU and LFU. Yes. After LRU and LFU, there are the hybrid algorithms like LRFU and CRFP, LR plus 5 LF. These algorithms combine between the LRU and FLU techniques. Okay, wherever they are self-tuning and can switch among, unlike cache replacement, adaptively and as a result of the changes of the access pattern. But these algorithms, however, don't use the page sizes. Okay, use or consider the recently, consider the frequency, but don't consider or don't use the pitch sizes or the size of the pitch in the cache. Okay, and time distance among the two last sequential accesses. Okay, to decide what is the affected pitch. Okay. After that, the algorithm WRB, the WRB and DWRB. This is the WRB depend on. Oh, sorry. The WRB depend on depend on the weighting of the weighting of the object, rely on the page ranking in the cache replacement, depend on the recency and the frequency, frequency, but depend on the recently used, but don't take account doesn't take the account of the access times of the object, or the size of the object. Okay. After that, this is algorithms like genetic algorithm. This is a paper deal with the size. Okay, this is advanced or adaptive algorithm for the web cache placement policy, which use the size and heat and times, the lifetime of the object. Okay. In the cache, and heats. This is the number of access of object, and it exists in the cache. But it is not accurate. It's not accurate, as it must consider the number of access of that object. If the yes, I mean the heats. The heats is the number of access of object. Okay. And the object exists in the cache, but doesn't consider what is the number of access of the object when the object is not exist in the cache. Okay. In this proposed algorithm, I used some attributes of block, like recency, frequency, time distances, action function, and fitness function. Okay. And deal with this attribute as genes in the chromosome in the genetic algorithm. Like the recency is the gene, frequency, time distances, and fitness function. The recency, this is a number of access of data. This is a recency is the number of other unique blocks access from the last reference to the current time. Like in this example, the recency of number one, of block number one equal to, yes. This is the recency. And the frequency, the number of time that the block in the buffer has been referenced from the cache objects. Okay, this is a frequency. Okay, the time distance, this is the third attribute of the block. The time distance is the average time of distances. The average time of distances, delta tk, is calculated from this equation. For example, when I calculate the delta tk, or the average of time distances, this is the average, not the time distances. In the previous papers, they consider time distance the last two axes of the object. But in this case, I consider the average of time distances. Start from inserting object in the cache to the last the last time the object accessed from the cache. This is as the delta tk. Okay. For example, begin from time 0 to time k. Yes, this is the equation to calculate delta tk. From this equation, delta t, this is the time distance, namely in the time difference among the two sequential axes of the block. The two sequential axes of the block. Okay, this is the delta k capital. Okay, block, say block I referenced it at time 0, time 1, time 2, time 3. This is the 4 times the block I referenced it. Okay. Sorry. In this example, continue. Time 0, time 1, time 2, time 3. This is the 4 times the block accessed in these 4 times. Okay, and delta k calculated from t0 to t3 in this equation. The delta t1 calculated from this equation. Okay, where delta t0, delta small 0, this is I suppose this it is equal 1. for the first time, okay? And delta T2, okay, calculated from the previous equation and so on, yes? And delta CC3, okay, and so on. And the action function, this is the important parameter. Why this is important parameter? Because normally, if I request a block, we must consider the size of the block. Okay, when there is enough space in the memory, in the cache, okay, we must check the size of this room or of the free space in the cache. If this free space in the cache is equal or larger than or equal the requested block, then this action function will be equal 1. Okay, but if the affected object size is more than or equal the requested object size, the action equal 1. Okay, but if the affected object size is not more than or equal the requested object size, this is action equal 0, and and then this equation will be equal 0. Okay, this is to be ensured there is a sufficient space for the incoming object or not. Okay, and not all the object in the cache. I don't need to calculate the fitness function for all the objects in the cache. I will calculate the fitness function for the objects whose size larger than or equal the requested object. Okay, the requested object size. Then finally, the fitness function. The fitness function, this is a function which calculates the weight of the object. Okay, the fitness of the object, the strength of the object. Okay, and yes, okay, and this.
Sorry, Amar, but please conclude your presentation.
Yes. Sorry. Yes.
Yeah.
During
Thank you.
2 minutes. Okay. These proposed algorithms depend on proposed algorithms depend on if the block in the cache or not. If the block in the cache, okay, then the frequency increased by one, and recency equal 1, and this is the equation of the delta t. If the object in the cache not exist in the if the object not exist in the cache, check if this object in the queue or not. This is a queue. This is a list out of the cache, contains the information about the objects affected from the cache. Okay, if this object requested object exists in the queue, yes, then check if the services if there is a free space or not. Okay, and calculate the GA function, the genetic algorithm function, to remove the object to queue. Okay, and they check if the object is not exist in the cache. Check if the free space is larger than or not, and check and increase. And set R and F and delta T equal 1. Okay, in all cases. We must check the number of hits and the number of hits. This is the number of times the requested object exists on the layout or not. Okay, when the requested object exists in the layout, this is at H. O otherwise. Okay, if H increases and H minus O more than 3, then the policy trend to LFU, and this is the equation of the fitness function. And otherwise, if O plus H more than 3, then the algorithm turned into the LRU. Okay, and if O minus H less than 3 or H minus 1 less or equal 3, this is a hybrid. We use the frequency, recency, the both frequency and recency in the equation of the fitness function to decide what is the affected object. Okay, and this is the rules of genetic operators in this algorithm. I updated the frequency and recency in this algorithm. Sometimes I increase frequency by 1. This is a mutation, and the fitness function calculated according to the previous conditions. But the crossover operation can't be used because the genes are interrelated and constrained. This is a special case in some cases if the fitness function of two objects is equal. If the K1 or K2 in the layout, object K1 and K2 in layout, choose the first object in the affected from the cache, because the layout or the queue take the first in first out method. Okay, if one of them in L out only, then the other will be affected. And if K1 and K2 out of the layout, then we use the k-nearest neighbors to decide what is the object will be affected. Okay, and in general, this is the information I used in the experiment. Number of requests. This is some blocks from 1 to 500 blocks with size 136 mega in the cache size 100 mega. And this is the number of requests. This is a huge number of requests to make the cache sometimes full or sometimes empty. Okay. And this is the case 2, this number of requests, and block IDs from 1 to 1,500, and the size 285 mega in the cache 200 mega. And this is and so on in case 3. And this is the average hit rate of the blocks in the cache. Finally, after I do this information in the experiment, and I compare the result of the GE, the proposed algorithm, between and the WRB. This is the weight replacement policy, and this is the hit ratio of GE, and this is the time. Okay, this is the hit ratio. Okay, but this is the time is less than the WRB. Okay, and this is the time between the time is less than the WRB. Okay, and this is a graph for this result. Conclusion: I know that L out or Q, which contain the objects affected from the cache, will be overhead on the runtime and will be increased and to grow during the processing. And for future work, it should be tuned and optimize the size of L out to avoid the yes. Okay. Okay. To avoid or to overcome the difficulty or time difficulty of the layout. Okay. Thank you. Any questions?
So you have concluded with the same point what I was about to come. Only thing what I really am curious to know is, currently the hardware compatibility is increasing very well, right? Cache size
increasing what? Sorry.
The cache size, hardware compatibility, the cache size, cache memory is increasing quite evidently, right? So the days will not be far away that cache memory could be higher in the place. So the space would not be the main constraint. What I feel is required is the paging, the searching, the sequencing,
Yes.
So, your fitness function should more precisely be on first the sequencing means, I mean, indexing of the words or phrases which has been, or maybe any file or anything which has been very frequently short, very frequently asked. Do your fitness function is working on that only? But yes, we may make that fitness function more weighted on the search or the frequency of the data required.
Yes. Yes. Okay.
So keep the good work done. Good work. Good going.
Okay. Thanks very well. Thanks very much. Thank you very much.
Uh,
All the best.
Thanks,
Okay.
Omar. Yeah.
Thanks.
Yeah.
Goodbye.
Bye.
Bye bye.
So we move ahead with our next presentation. Our next presentation title is uh, Electricity Storage System, a Gravity Battery.
Hello.
Yes.
Hi, this is Tamanna. I'll be presenting. Could you please allow screen sharing to my other device I've logged in using today?
Okay. So Tanvi will start the presentation.
No, I will be presenting.
You are presenting, and you will share the presentation, right?
Yes.
Okay. Yes, you have the right to for the presentation, so you can share it right now.
Right. Is the screen visible?
Yes, it is visible. Yes, perfect. Please stick to the time. Thank you.
Yeah. Okay. So I, along with my two fellow mates, Shubham Yadav and Sandeep Kumar, have worked on this paper with the Professor Dr. Chaturvedi and the students of BTech fourth year Electrical Engineering, Faculty of Engineering, Yalda Educational Institute, Agra, Uttar Pradesh, India. Uh, our professor was to present this presentation, but he's not able to join due to some unavoidable reasons. So basically, we're not presentation ready, but nevertheless, we want to show our work. I'll be reading out a few things because the presentation itself is self-explanatory. Just a second, echo in my voice.
If you could please use a headphone, or you can sit closer to your system, that could clear your voice.
Hello.
Yes. Yes,
Yeah.
you are logged in from two devices. Might be because of that.
Yes. Yes.
So
I am.
please, yes, please make one speaker off. So
Hello.
yes, perfect. You can go ahead.
Yes, you are audible. You can go ahead.
Am I audible now?
Yes, you are.
Okay. Fine. So let's begin. The abstract drawbacks of existing energy storage systems, for example, lead acid batteries, lithium-ion, have their adverse effects like environmental impacts, pollution, fuel, disposal problems, efficiency, etc. Renewable energy sources like solar and wind can solve these problems to a greater extent, but they have their own limitations like intermittency and space requirements of hydropower plants. So the baseline is resources are free, but not always usable and storable. Basically, we lack the technology to use these resources. So in this paper, a gravity battery is proposed, and the concept of gravity battery is pretty simple: storage of potential energy, which is converted back into kinetic energy to run a generator and produce electricity again. The paper is divided into two parts. First part is review of the existing storage systems, and which also promotes the idea of gravity battery. And the other part is design and development of the prototype. Three of us especially have been extremely instrumental in the design. So we'll be discussing that. Introduction, electrical demand is increasing at a faster rate. 65% of total power is used by fossil fuels and it affects the environment. So we're continuously trying to increase the share of renewable energy in the grid. To maintain continuity and reduce variability, the energy storage becomes essential. What are the determinants of a useful energy storage solution? Response time to the demand, energy loss during storage, energy density, rate of charging. For better, greener, and dynamic grids, we need significant new and better energy storage solutions. And we move on to the review of the existing ones. Fossil fuels, they are the most used form of energy. The advantages, they are portable, the transportability of their stored forms is easiest. Disadvantages cause global warming because they have a lot of carbon content. They're non-renewable, as we know, and unsustainable. Renewable energy sources like solar and wind have disadvantages like intermittency and reliance on weather and climate, so they're irregular, dynamic, not readily available at the time of need as there is no storage system. Hence, there arises a need to store this renewable energy. Lithium-ion and lead-acid batteries commonly used for small and medium-scale energy storage solutions. Disadvantages, environmental pollution. Lead acid is bad for health and storage capacity is limited. Pumped hydropower, a large storage solution in mega. Water is pumped to uphill during excess electrical power, and this high head water is made to flow back downhill to generate power. And this is again the same concept. Disadvantages are it requires a specific geographical location and a lot of space, and the installation cost is also high, very high. Then the evaporation of water is another problem related to pumped hydropower plants. Gravity batteries can address all these problems. The problems are intermittency, rapid response to large fluctuations in demand, making a responsive grid, minimizing the requirement of backup generation plants. This point will be discussed in the next slide. Has several economic and ecological benefits. Yes, the modern grids presently do not have any storage. These will add to grid resilience. These can help in meeting the demand of electrical energy during the peak hours. The next point is energy. These storages can offer energy during off-peak hours when excess heat energy is available and put up for sale when there's a shortage of energy in the grid. So these can act as backup. This is one of the major points in formulation of smart grid, which is two-way power flow, unlike the one-way power flow, which is possible before introduction of smart grid. So as you can see in the diagram, before smart grid, one-way power flow, generation stations providing electricity or energy to the consumers. Here you can see consumers and there's a interaction between consumers, two-way interaction. For example, capacitive plants also supplying back to the main plants, generating plants. Advantages, we can conclude the advantages of gravity batteries as a more efficient grid, which is more resistant to any disturbances in the load or source end, more efficient grid, reduction in carbon dioxide and other emissions, increase in the economic value of wind and solar power, which is restoring renewable energy, helps in income generation, which will be discussed. Yeah, here comes the problem formulation. We need something, clean energy is generated and efficiently stored, then this should not only satisfy the demand, but also become the source of income. For example, a PV solar panel mounted somewhere and agricultural farming can be done under that PV solar panel. Similarly, wind power farming can also be done. So this reduces carbon footprint. The only problem of these renewable energy sources is intermittency, which can be overcome by an efficient energy storage system. Here comes the point. We need something to store clean energy in a different form, thinking out of the box. Need analysis, as discussed, there's a need for such a big storage system that is required to commercialize new battery technology and draw inspiration instead from the granddaddy of grid storage, which is pumped hydro. What is the design concept? As I said, a gravity battery stores energy in the form of potential energy by elevating a large weight using an electrical power to regulate an electrical drive. At the time of discharge, this potential energy is converted into kinetic energy by decreasing the height of the large weight, rotating a generator depending on the necessity. A pump hydro is also the same thing, storing potential energy in the form of water, and it is then brought down onto the turbine. Similar concept. This is the design concept, gravity battery charging. We do not allow deep discharging. The higher levels show the charging of the battery, which is under the windmill. Design and development of the prototype. This paper demonstrates the working concept of the gravity battery. It fulfills the need of storing clean energy. We have developed the prototype at a lab at Department of Electrical Engineering, Faculty of Engineering, Jalbagh Education Institute, PDI, Agra, Jalbagh, Agra, India. This is the schematic diagram. I'll read out the steps. There's a weight which is lifted up by a hook string system. As you can see here, in our case, we use 5 kgs of weight hook string system. When the motor runs on electrical energy, the shaft rotates and consequently the string lifts the weight up. Gravity battery gets charged by rotating the pulley to lift large weights at maximum height and therefore stores the energy by virtue of its position, which is known as gravitational potential energy. So the weight gets lifted up and the potential energy gets stored. Here is a motor. This is a pulley and a chain system. Then here is a pulley drum. The weight gets lifted up. Next point is, now the switch is changed from charger to generator mode and generates power by rotating the string coil in the opposite direction. So the second point was motoring action. Third point is generating action. It is left free. The system is left free and the weight is allowed to fall freely. Not in this case. We have used a gear system here, so not freely here. The gravitational potential energy is released when the weight is brought down and in turn produces energy. Gears and flywheel system has been used so that less distance traveled can produce sufficient number of rotations for the generation process. This energy can be used at the time of need. And this is the rest of the circuit. Gearbox, flywheel, here's a dynamo, which the stored energy into electrical energy, and the LED, here is an LED. Parts and specifications, we used a Viper motor, 12 volts, 10 to 25 RPM, battery, dynamo, electrolytic capacitor. Capacitor was used to avoid deep discharging and store some voltage, initial voltage. Electronic diode, 2 gears and a gearbox, flywheel, pulley, belt system, LED strip. The strip was 3 meters long, 12 volt LED. 2 multimeters were used to note 2 different readings and a 5 kg weight, as I said. This is the photo of our model. It looks fine. Prototype model of gravity battery. As I said, it's visible, flywheel, gearbox, then this is the battery, Viper motor, multimeters, and let me show you the video of our model. Is it visible? No, I need to share my screen again.
you have to share the video.
Yeah. Is it
Okay.
visible? I'm sorry for the
Yeah,
inconvenience. It is rotated.
It's fine. It's fine. You just play
it's
it.
fine. You may play.
The weight is getting lifted. The system is little weak. Is little weak. And we release it. Yeah. So I go back to the presentation. So the height to which we lifted our weight was 1.62 meters, 5 kg. This is the simple equation mgh potential energy. The maximum energy that should have been stored was 79.38 joules. Theoretically, calculating the ideal time of fall using this equation, mgh equals half mv square kinetic energy, and the velocity came out to be, ideal velocity of fall came out to be 5.634 meters per second when the conditions are at no loss, ideal conditions. But the observations were for a particular for this particular model prototype. So time of 10 seconds, time of fall 9.41 seconds, hence velocity of fall came out to be 0.172 meters per second, and we could just note the maximum output instantaneous voltage and current values, 8.46 volts produced at 0.14 ampere. We were we were taking this. We were actually trying to calculate the efficiency of the prototype, but we couldn't. So we hope to do so as soon as we get back to our college after this corona phase. And we have thought of a few things like using energy meter for the calculations. Conclusion: the proposed gravity batteries do not have any leakage current as in lead acid lithium-ion batteries. There is no environmental pollution like acid fumes in lead acid batteries. Life of these batteries is quite long, no disposable problem. The most important thing in these batteries is quite high efficiency, which we will be calculating. The multiple weights may be used for higher energy storage, which I'll just show. The disaster management plan may be included in gravity battery energy storage solution. So this is the thought design of multiple. This the thought design of concept of multiple gate system, which can be used. Basically, our prototype is inspired from Energy Vault, the project of Energy Vault, Swiss-based company in which India is also a part. And the other reference that we used was Gravity. You can check out on Google. We may not be able to answer your questions, but we welcome suggestions and inputs so that we can take this project forward.
First of all, many congratulations for a novel idea. I just want to ask one thing. Are you an engineering student?
Yes, we are engineering, bachelor's BTech, bachelor's technology.
You are pursuing BTech? You are doing your BTech?
Yes.
Okay, an entire group is doing BTech and you are working with your professor, right?
Yes, we're working with the professor.
Okay, then very good work, excellent, and all the best for your project.
Yes.
Yes, great work, great work.
Okay. Thank you, Tamanna, for the presentation. Now we are moving towards our last presentation. It will be by John Colaco. And the paper title is IoT based data acquisition system for real-time pressure measurement of seawater. Uh, yes, John Kolako, you can share your presentation.
Hello,
Yes.
you can see my screen.
No.
Oh, wait 1 sec. You can see my screen now.
It's coming.
Yes.
Yeah, it's visible now.
Yes, please go ahead with the presentation and
Okay.
please
I,
stick to the timeline. Time.
yeah.
Yeah. Thank
So
you.
my topic is title for this paper is IoT-based data acquisition system for pressure measurement of seawater. So we know the things, the recent things, the things that are going on, the rise in sea level. Okay. So now, so the main purpose, I'll tell you the main purpose what's happening is that we know the tides which are called for rising and falling of Earth's ocean surface. This is basically because of the tidal forces of moon and sun acting on it. So what happens here is that there's a gravitational attraction, okay, that varies with time and space. So this gravitational attraction, okay, actually the bulges of the sea, okay, it bulges of the sea of very, which is very close to the moon, and hence the earth, as earth rotates from one point, there will be two high tides, okay, and two low tides during full moon. And this, when the new moon comes, when the sun and moons they are lined up, you'll be seeing the highest rise. So now these tides affect the depth of marine and estuarine water bodies, and hence produce the tidal streams which are oscillating current. Okay, now these sea tides and waves plays a major factor in determining the safety of coastline. So what happens here is that when there is a land rise, the sea rises little. However, when moon passes over this overhead, maybe directly the land rises more than the sea, and sea drains away. The difference in the risk rise between the land and the sea, which actually determines the tidal height. Hence, thinking of all these thoughts, the pressure measurement of seawater, okay, we have done. So method adopted for this is measuring the sea level, that is by detecting the hydrostatic pressure with respect to its water column, okay, that will lie over this pressure transducer and determine its height. So next is so now this has been achieved by a system of data acquisition system, okay, which is basically you can call a process which can a sample signal, okay, for measuring the real world physical conditions. It can be anything physical such as temperature or maybe heat, okay, and converting those resulting samples into a numeric value, digital numeric value that can be viewed or displayed. Okay, so this data acquisition system, we know it consists of a sensor or transducer, then signal conditioning, A to D converter, microcontroller. So in this we have used ARM7 microcontroller, storage tray, we have used multimedia card, and a computer. So this everything has been controlled by a C program. Okay. So in this research paper, okay, we have proposed this real-time data acquisition system. So what happens here is that, as seen figure, that the sensor will convert the physical phenomena, which is of pressure, okay, and will convert into noisy electrical signal. Now this noisy electrical signal have to be signal conditioned by filtering, okay, then linearizing the signal and amplifying the same, so that it becomes easy for it to convert to convert this analog signal into a digital value, and same is stored in a storage device. Okay, the next is, so this pressure sensor this system can be deployed on a subzone. So we have used a piezoresistive pressure sensor. Okay, now what is piezoresistive pressure sensor? We have already know about most of us. Is its resistance depends upon the, you know, directly upon the length of a conductor and inversely proportional to the cross sectional area. Okay, so what happens is this has a sensitivity that depends upon the thickness of silicon diaphragm. So the resistivity value of this diffuse semiconductor resistor and linearity depends upon this semiconductor resistor. Now, what happens here is, so this paper is divided into two sections. One is data acquisition and transmission, another is data receiving. Okay. So now data is sensed. Okay. So now data is sensed by pressure, which is analog electrical signal. Okay, the overall idea I'm just explaining. Okay, the analog pressure then sampled and converted into a digital form. Okay, and then fed into a storage device. Okay, then from the data is read from the storage device and sent read on PC and sorry, and it is displayed on. Okay, uh, okay, and it is sent via DGXP wireless technology, which is IoT enabled technology. Okay, now I'll just explain the piezoresistive sensor once again. So what happens? It is a when the strain, you can see the strain. Okay, we get of semiconductor material like silicon is stretched. Okay, when it is stretched by some pressure or force, okay, that's the electrical change. Okay, now this electrical change is recognized by a diaphragm. So here the diaphragm, which is at a strain attached to diaphragm. So when sensor element is deformed due to applied pressure, so there is an electrical change. Okay, and it is measured by using a Wheatstone bridge. Okay, and convert into output voltage. Okay, so now, okay, next is a receiving unit. In this, a pressure parameter values are received using a wireless DGXP technology in the office of NIO for further analysis. Also, it can be uploaded on a cloud server for monitoring and analysis on real time. Okay, so I'll just explain the flowchart of this. So what happens, what we did is, first step is initializing the UART, that is universal asynchronous receiver transmitter, okay, for microcontroller to communicate with computer, okay, using serial port, okay, which involves the setting or resetting the different bits in these special function registers. Then second is initializing of the SSP, that is serial synchronous port, okay, which is used as serial peripheral interface. And third is initializing MMC multimedia card, which should be set in SPI mode to be used by microcontroller, and is initializing real-time clock, that is for storing and displaying the date and time. Okay, now what happens here is, okay, pressure is sensed, then next pressure is sensed. Okay, pressure is sensed and converted data produced by sensor into analog electrical voltage, which is a noisy electrical voltage. Okay, now this analog electrical voltage is a real-time voltage, and hence is proportional to the pressure of the water, okay, at in real time. Okay, this real time analog voltage is then presented at analog to digital converter. Okay, analog digital converter. So now what we have done is here is that we have taken the necessary information in terms of time, date from our user input, okay, and a time interval between the samples, number of the average the to be taken of number of samples, then setting the date and time, okay, in the real time clock, and then sampling in A to D converter, okay, to check the time interval between the samples, and then give necessary signals, initiating data serially in variable and taking average of the samples. So the sample data is then converted into a string of characters for storing the data in the multimedia card storage device, so that when you are reading, it can directly be printed on the screen. And to store data, basically we have to the block length should be set. Okay, then reading the store data from the multimedia card and displaying it and sending it wirelessly using a DGXP, which is IoT based technology. So this is a overall idea. Okay, this is so hence we got a sample of sample 1 for 16 millivolt, 16.32 millivolt, and sample 2 for 16.21 millivolt. Okay, the conclusion and future research is that the future research can be used. Conclusion, we conclude that the sensor is very accurate piezoresistive sensor. Okay, and it is we have stored the data on multi without any error and read from that multimedia card and displayed on PC. The future work of this can be carried out using a Raspberry Pi, or you can use Arduino. Okay, you know the Raspberry Pi, okay, which has a high processing power, and it's almost like a mini computer. Okay, and analysis we can do using importing on a MATLAB. Okay, using MATLAB data equation toolbox. Okay, you know, it has a very excellent platform for configuring any sensors. Okay, and it can be also be done using um, LabVIEW. Okay, it's another very good platform, which is a graphical programming LabVIEW. So these are the few of the references we have referred of some papers. Okay.
So, first of all, very interesting one. Seeing this kind of sensors first time. My very generous question is: you have
Yes,
implanted
sir.
sensor somewhere within the sea coastal area, right?
Yes, sir.
There are chances of the hardware getting wear out very fast
Yeah.
because of the moisture, because of
Yes, sir. That
the
is.
sea salt water.
Yeah, yeah.
So
That
you
is
have
a.
to look for that. You have to look for that fast. Second thing is you have a real-time data acquisition, right? So
Yes, sir.
your sensor should send your data immediately whenever the sensor senses.
Yeah, that is a.
And the third and the third thing, which is very important, is there has to be a system integrated with the sensor, which has the historical data also, which processes the data and gives the signal accordingly, which will not happen immediately, but over a
Yes.
period of time. After
Yes, sir.
collecting years, 2 years, 3 years, 10 years, 15 years data, your system would be strong enough.
Yes, sir.
So your work starts from here only. You build a system, you
Yes, sir.
build an algorithm, you
Yes,
build
sir.
a process in a way where in future also
Yes.
at that time sense data is matched with stored data
Yes. Yes.
and
Correct, sir.
triggers the
Yes. 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 That is
signals
actually.
accordingly.
Yeah, actually, I was working on that but using the Raspberry Pi. What I'm doing, it's I'm also trying to control the flood also in case of some big rise in sea level. Suddenly, some tsunami happens. So I'm also trying to add pressure level sensors to measure directly and send, so it becomes a real human saving life, especially on Indian coast. I was working on it.
All the best for that and
Yeah.
keep up
Thank
the
you,
good
sir.
work. Would like to
Thank you,
see
sir.
some
Yeah. Good
miracles
night,
from
sir.
your side.
Yeah. Thank you, sir, very much.
Welcome, Amit sir.
Yes, yes. Now for closing remark, I like to invite Amit Joshi. Yes.
First of all, let me thank Dr. Nasser Pathak, who has taken a lot of pain and lot of time at this point of time in India, because it's already 10:45 in the night in India. And token of appreciation from our side to you, sir. And we appreciate your collaboration, your support, and your association in all our
Anytime, yeah.
future research initiatives. Thank you very much. My next part of thanks is due to the authors who have contributed their papers. See, what I believe is the cycle time for a paper to be submitted to a conference and finally to be published is approximately 6, 7, or 8 months in different circumstances. But for this conference, we can believe that it's 3 to 4 months before the conference, and maybe another 3 months to be for the paper to get published. So you have been patient so much time, and we again request you to be patient. If you have any queries till the publication comes online in next 2 to 3 months, you write to us. We will be happy to answer you and to support you in the best possible way. It's in currently in London. It's summertime, so it's really amazing. If you are in and around London, please go and visit. Or if, even if in Europe, it's really amazing time and climate to be there. And what I can say is to be be safe, stay safe, and I hope that COVID-19 will soon be a thing of past, and we will overcome this pandemic. Everyone, every individual, every organization is doing their own part in fighting it, and we will again meet soon, maybe in the year 2021 for World S4 21. Till that time, stay safe, stay happy, and stay blessed. Thank you very much. And once again, thank you, Dr. Nazar Pathak. Over to you,
Thank you,
Mr.
sir. Thank you very much
Yes, thank you,
for the
everyone.
opportunity
Bye.
and all the best.
Yeah,
Bye. Good
thank you.
night.